Good morning, students. Now let's go to start our new chapter. What is that? Chapter 14, symmetry. Okay. What is meant by symmetry? If a line divides a figure into two identical halves, a line divides a figure into two identical halves, the figure is said to be what is that? Symmetrical. This figure is said to be symmetrical about the line, and the line is called what is that? Line of symmetry. And the line is called what is that? Line of symmetry or axis of symmetry. So for example, see this diagram here. This diagram is an isosceles triangle. We know what is that? What is meant by isosceles triangle? Isosceles triangle means two sides of a triangle are equal in measure. So here in this isosceles triangle, we can draw a line segment from a vertex of a triangle to the midpoint of the opposite sides. We can draw a line segment from a vertex of a triangle to the midpoint of the opposite sides. Now these two triangles are divided in these two identical triangles. These two triangles are divided in the two identical triangles, triangle 1 and triangle 2. So this two triangle is called what is that? Symmetry. These two triangles is called symmetry about this line segment. So this line segment is called what is that? Line of symmetry or axis of symmetry. What is that? If a line divides a figure into two identical halves, this line divides this figure into two identical halves about the line, and the line is called the line of symmetry, and this line is called what is that? Line of symmetry or axis of symmetry. So see another one example here. Now we can draw a rectangle, and these rectangles are divided in the two identical shapes. What is that? First shapes and second shape. These two shapes is called what is that? Symmetry. These two identical shapes is called what is that? Symmetry, and this line is called what is that? Line of symmetry or axis of symmetry. So our next concept is what is that? Line of symmetry for regular polygons. A regular figure is said to have as many lines of symmetry as the number of sides. So first, what is regular polygon? Regular polygon means all the sides are same length. All the sides are same length and all the angles are equal. We know what is the types of this triangle. This is an equilateral triangle. Equilateral triangle means all the sides of a triangle are equal and all the angles are equal. Next, what is that? Square. We know square is a regular polygon. All the sides of the square are equal length and all the angles are 90 degree. How to draw the line of symmetry? We can draw a vertex of a triangle to the opposite sides. We have any other method to joining the line of symmetry? Yes, we have another way to draw the line of symmetry. So it have three lines of symmetry. It have three lines of symmetry. So the line of symmetry of an equilateral triangle is 3. How many line of symmetry for a square? We can draw like this and this types also. Any other way to draw the line of symmetry? Yes, we can join the diagonals of the square. So this diagonal divides the shapes into two identical shapes. Next. So how many line of symmetry it have? 1, 2, 3 and 4. So a square have 4 line of symmetry. So what is our definitions? A regular figure is said to have as many lines of symmetry as the number of sides. So next concept, rotational symmetry. What is meant by rotational symmetry? If after rotation an object look exactly the same, if after rotation an object look exactly the same, we say that it has a rotational symmetry. Suppose, so this is in the shape of equilateral triangle. Now we rotate the equilateral triangle based on 60 degree. So this triangle becomes the same position only. So this is called what is that? Rotational symmetry. If after rotation an object look exactly the same, we say that it has a rotational symmetry. And rotation turns an object about a fixed point. Rotation turns this object about this fixed point. This fixed point is called what is that? Center of the rotation. So this point O is called what is that? Center of rotation. So next, The angle by which the object rotate, the angle by which the object rotate is the angle of rotation. So what is the angle of rotation for this shape? An angle of rotation is 60 degree. So here an object rotate and exactly the same position is called the rotational symmetry, and the fixed point is called what is that center of rotation, and angle by which the object rotate is called what is that angle of rotation. Then our next concept, what is order of rotational symmetry? What is the order of rotational symmetry? In a complete turn of 360, in a complete turn of 360 degree, the number of times an object look exactly the same is called the order of rotational symmetry. The number of times an object looks exactly the same is called what is that order of rotational symmetry. Here, now we take the shape of a rectangle. We know what is a rectangle. Opposite sides are equal in length and all the angles of a rectangle are 90 degree. So now we rotate this triangle first times. So now we rotate this rectangle first times, then it rotates the second time becomes like this, and this rectangle also rotate the third time it becomes what is this position, and finally it rotates the 360 degree. That means final position it becomes the original shapes. So how many times an object rotate the same position? How many times an object rotate it becomes the same times? So 1 times and 2 times. First time we rotate this position is changing like this, and second time we rotate the same position, also the fourth time. But how many times an object look exactly the same position? 1 time and 2 times. 2 times an object rotate the same position by based on 90 degree. So in a complete turn of 360 degree, the number of times an object looks exactly the same is called the order of rotational symmetry. So what is the order of rotational symmetry for the rectangle? The order of rotational symmetry is 2. What is the order of rotation? 2. So we know clearly what is the order of rotation. In a complete turn of 360 degree, complete turn of 360 degree, the number of times an object look exactly the same. Number of times, how many times? 1 and 2 times. Number of times an object look exactly the same is called what is that order of rotation. So order of rotations in a rectangle is what is that? 2. So next our exercise 14.1, first question. Copy the figures with punched holes. Copy the figures with punched holes and find the axis of symmetry for the following. We want to find the axis of symmetry. That means we want to draw the axis of symmetry for the following. How to draw the axis of symmetry? We can draw like this or like this. So this is an axis of symmetry for this square. Any other way to draw an axis of symmetry? We don't want to draw, we can't draw the axis of symmetry for the diagonal because this position is not become the same identical shapes. So we can draw like this also. Now it became the identical shapes, and this method also became the identical shapes. So what is the line of symmetry for this B questions? We can't draw this vertically and horizontally. Suppose we draw these vertical lines, suppose we draw this horizontal line, it does not become the identical shapes. So we can draw the line like this method only. So this is an line of symmetry or axis of symmetry. How to draw the axis of symmetry for the C question? So this is also same way. We can draw like this method only. So D question, we can draw like this. So next remaining questions are homework in this pattern. So in this remaining questions, you will draw the axis of symmetry in your book itself. Next our exercise 14.1, remaining questions are homework. What is that? Your second pattern, third, fourth and sixth patterns are your homework sums. So next what is the fifth pattern? Copy the figure given here. Take any one diagonal as the line of symmetry. Take any one diagonal as the line of symmetry. So take any one diagonal as the line of symmetry and add few more squares to make the figure symmetrical about the diagonal. We want to add few more squares. this diagram became a symmetrical shape. So we can draw like this. Now we clearly it becomes the symmetrical shapes. It becomes the identical shapes. So we can draw the second diagonal also. So this method also, these shapes become a symmetrical shapes. So what is the final question? Is there more than one way to do this? Yes. Yes. Yes, there are more than one way. More than one way to do this. So next, will the figure be symmetry about both the diagonal? Yes. So yes, this figure symmetrical about this both the diagonal. Yes, the figure will be symmetry about both the diagonal. Next, our seventh pattern, state the number of lines of symmetry for the following figure. State the number of lines of symmetry for the following figures. So first A cosine. What is A cosine? An equilateral triangle. What is meant by equilateral triangle? Equilateral triangle is a regular polygon of three sides. So it have three line of symmetry. So we discussed also an equilateral triangle have three line of symmetry. Number of line of symmetry is what is that? 3. Next, what is an isosceles triangle? Isosceles triangle means only two sides are equal. Only these two sides are equal. So an isosceles triangle which have how many line of symmetry? Only one line of symmetry. So it becomes the two identical shapes. Next, third, a Escalant triangle. So Escalant triangle means all the three sides are different. All the three sides are different. So we can't draw a line of symmetry. So this is no line of symmetry. Isosceles triangle have two line of symmetry and the Escalant triangle have no line of symmetry. Then equilateral triangle have three line of symmetry. Equilateral triangle, three lines of symmetry. Isosceles triangle have only one line of symmetry. One line of symmetry. So next, D cosine. So what is our D cosine? D is a square. We know a square is a regular polygon of 4 number of sides. So it have 4 line of symmetry. We know a square have 4 line of symmetry. So it has 4 line of symmetry. So next, D cosine. Next, our E cosine. What is E cosine? A rectangle. So we know a rectangle have only 2 line of symmetry. A rectangle have how many line of symmetry? 2 line of symmetry. It becomes a identical shapes. So rectangle has 2 lines of symmetry. Next, F cosine. F cosine is what is that? A rhombus. F cosine is a rhombus. How many lines of symmetry for the rhombus? We know rhombus has 2 lines of symmetry. It becomes the identical shapes. 2 lines of symmetry. Next, G cosine. What is G cosine? A parallelogram. We know what is a parallelogram. Opposite sides are equal in measure. Is called what is that? Parallelogram. So, how many line of symmetry for the parallelogram? We know parallelogram have no line of symmetry. No line of symmetry. So, what is H cosine? A quadrilateral. Quadrilateral means just a 4-sided polygon. So this is also has no line of symmetry. Next, I cosine is what is that? I cosine is a regular hexagon. Hexagon means is a 6-sided polygon. Regular hexagon means all the 6 sides of a polygon are equal in measure. So how many line of symmetry for regular hexagon? 1, 2, 3, 4, 5 and 6. So regular hexagon has what is that? 6 line of symmetry. 6 lines of symmetry. So next, J cosine a circle. J cosine circle. How many line of symmetry for a circle? We know a circle have infinitely many line of symmetry. That means the number of line of symmetry for a circle is countless. So what is the number of line of symmetry? Infinitely many line of symmetry. So next, our 8th question. What letters of English alphabet have reflectional symmetry? That means symmetry related to mirror reflection about a vertical mirror. Next, a horizontal mirror. Next, what is that? Both vertical and horizontal mirrors. First, what is A? A letter A have a vertical mirror. So a vertical mirror have letter A, and B have what is that? Horizontal mirror. B have what is that? Horizontal mirror. Then C is also a horizontal mirror. C is a horizontal mirror. D is also horizontal mirror. E is also an horizontal mirror. But F is not vertical and horizontal mirror. G is also not vertical and horizontal mirror. So what is H? We know H is a vertical mirror. We can draw like this. And this is also a horizontal mirror. So this letter H is both vertical and horizontal mirror. Next, I is also what is that? Both vertical and horizontal mirror. The letter I is also both vertical mirror and horizontal mirror. C is a horizontal mirror. D is a horizontal mirror. E is a horizontal mirror. H is both vertical and horizontal. The letter I is also both vertical and horizontal. So next, JKL is not a vertical and horizontal mirror. M is a vertical mirror. Next, N is no vertical mirror and horizontal mirror. The letter O is a vertical mirror and O is both vertical and horizontal mirror. So this is a horizontal mirror, both vertical and horizontal mirror also. Next, so letter P have no line of symmetry, Q or S have no line of symmetry. What is T? T is a vertical mirror. U is also a vertical mirror, and V is also a vertical mirror. Then W also a vertical mirror. Next, the letter X have both vertical and horizontal mirror. So X is a vertical mirror, horizontal mirror, and both vertical and horizontal mirror. Next, the letter Y have the vertical mirror. So Z is no vertical and horizontal mirror. So what are that? A vertical mirror have A, H, I, M, O, T, U, V, W, X, Y are vertical mirror. Then what is a horizontal mirror? B, C, D, E, H, I, O and X is a horizontal mirror. Then both vertical and horizontal mirror is what is that? H, I, O and X. So next, what is the ninth pattern? Give 3 examples of shapes with no lines of symmetry. So your ninth pattern is your homework sum. Next, 10th pattern. What other name can you give to this line of symmetry of an isosceles triangle? So line of symmetry of an isosceles triangle. Next, line of symmetry of a circle. So what is the other name of a line of symmetry for the isosceles triangle? We know a line of symmetry is drawn to the vertex of a triangle to the midpoint of the opposite sides. So this is called, what is that? Median. Median. Then what is the line of symmetry for a circle? In a circle, line of symmetry are passes through the center of the circle. So this line is called, what is that? Diameter. So this is called diameter. So line of symmetry of an isosceles triangle is called median, and line of symmetry of a circle is called, what is that? Diameter. Next, our exercise 14.2, first pattern. Which of the following figures have rotational symmetry of order more than 1? We just want to take which figure have the rotational symmetry of order more than 1. So first pattern is your homework sum. What is the second pattern? Give the order of rotational symmetry for the following figure. A question. The diagram is given. We want to find the order of rotational symmetry. What is the order of rotational symmetry for this diagram? We know a complete revolution of 360 degree. How many times it became the original position? We have 2 times it became the same position. When we rotate 180 degree, the shapes became the same position. Again we rotate 180 degree, the shapes goes to the original position. So what is the order of rotational symmetry? Order of rotational symmetry is equal to, what is that? 2. Order of rotational symmetry is 2. Second question, B question. So this diagram is given, angle of 80 degree and opposite angles are also same. Opposite angles are same because of the vertically opposite angle. So how many times it rotate to become the same position? Yes, the order of rotational symmetry is, what is that? Order of rotational symmetry is 2. So next, C question. So this diagram is given. What is the order of rotation for this diagram? We know this is an equilateral triangle, and order of rotation for this symmetry is, what is that? 3. Because if you rotate 360 degree in a complete revolution, it becomes 3 times as the same position. So order of rotation is, what is that? 3. So next, remaining questions are homework sum in this pattern. Next our exercise 14.3. Exercise 14.3, first pattern. So what is the first pattern? Name any two figures that have both line symmetry and rotational symmetry. Name any two figures that have both line symmetry and rotational symmetry. So what is that? So first one is circle. Next, square. So what is the first question? Name any two figures that have both line symmetry and rotational symmetry. So a figure which contains both line symmetry and rotational symmetry. So the answer is we can choose circle and square. So next our second pattern. Draw wherever possible a rough sketch of a triangle with both line symmetry and rotational symmetry of order more than one. Second pattern. First one. So we want to draw a triangle with both line symmetry and rotational symmetry of order more than one. So we know what is the equilateral triangle. And equilateral triangle have both line of symmetry and rotational symmetry of order more than one. We know. So what is that? An equilateral triangle. Then second problem is that a triangle with only line symmetry and no rotational symmetry of order more than one, which have no rotational symmetry of order more than one. So this is an isosceles triangle. Isosceles triangle have only one line symmetry. It have no rotational symmetry of order more than one. Rotational symmetry of order only one. So an isosceles triangle. Next what is the third one? Third one is a quadrilateral with a rotational symmetry of order more than one, but not a line of symmetry. We know a parallelogram have a rotational symmetry of order more than one, but this sets have no line of symmetry. So what is this? A parallelogram. Next. Fourth one. A quadrilateral with line symmetry but not a rotational symmetry of order more than one. So a quadrilateral have line symmetry. A quadrilateral have line symmetry but no rotational symmetry of order more than one. What is that? A trapezium. First one answer is an equilateral triangle. Second one answer is an isosceles triangle. Third question answer parallelogram, and fourth answer what is that? A trapezium. So next third and fourth pattern is your homework sum. Third pattern is your homework sum, and the fourth pattern filling the blanks is also your homework sum. Next what is the fifth pattern? What is our fifth pattern? Fifth pattern is name the quadrilateral which have both line symmetry and rotational symmetry of order more than one. Name the quadrilateral which have both line symmetry and rotational symmetry of order more than one. So we know square. So square has what is that? 4 line of symmetry. And what is the rotational symmetry of order? We know rotational symmetry of order also 4. So a square have both line symmetry and rotational symmetry of order more than one. So another one example is what is the rectangle. How many line of symmetry a rectangle have? We know a rectangle have 2 line of symmetry. And what is the rotational symmetry? Rotational symmetry also 2. So a rectangle is also have both line symmetry and rotational symmetry of order more than 2. Then sixth pattern. What is our sixth pattern? After rotating rotating by 60 degree about a center, after rotating by 60 degree about a center, a figure looks exactly the same as its original position. At what other angles will this happen for this figure? So we know what other angles will this happen for the figure. The other angles are the multiples of 60 degree. So other angles are what is that? Multiples of 60 degree. So our question is, after rotating by 60 degree, about a center, the figure looks exactly the same as its original position. At what other angles will it happen for the figure? The other angles are what are the other angles? 120 degree. That means multiple of 60 degree. 120 degree. Then 120 degree. After 120 degree, what is the value? 180. Then 180 plus 60 value 240 plus 300 and 360 degree. So after rotating the angle of 120 degree, 180 degree, 240, 300 and 360 degree, these shapes become the original shapes. Next, our seventh pattern. So, seventh pattern, first Roman. What is that? Can we have a rotational symmetry of order more than one? Can we have a rotational symmetry of order more than one whose angle of rotation is 45 degree? First, whose angle of rotation is 45 degree. So, first we check. We want to divide the answer 360 by 45 degree, which is equal to. So 360 and 45 is a multiple of 5. We can divide. How many 5s are 36? 7 5s are 35, remaining 1. What is that? 2 5s are 10. Next, 45 degree. 9 5s are what is that? 45 degree. So this is divisible by what is that? 9, which is equal to what is that? 8 degree. So what's the question? Can we have a rotational symmetry of order more than one whose angle of rotation is 45 degree? So, yes, it has a rotational symmetry of order more than one. Rotational symmetry of order more than one. So next, second pattern, what is that? Second Roman 70 degree. We know this is not a rotational symmetry of order more than one. So, no, it does not have a rotational symmetry. Rotational symmetry of order more than one. Because 70 is not a divisor of what is the complete division? 360 degree. So first one, 45 degree is given. 360 divided by 45 equal to 8 degree. So yes, it has a rotational symmetry of order more than one. But second question, no, it does not have a rotational symmetry of order more than one because 17 is not a divisor of 360 degree. So our chapter 14 is finished. Next our chapter 15, visualizing solid cells, is our deleted portion. We have two deleted portions. One is the practical geometry and visualizing solid cells are deleted portion for this year. Thank you, students.